Hello, everyone. Good to have an opportunity to talk with you. Talking about via drilling in ceramics, maybe you can do a little bit higher. We are laser guys, so but without special techniques, I would say 3, 4 to 1 is the very maximum. Okay, but not about drilling. I'm talking about our SSAIL technology, also laser related. And what we are doing with that on electronics, FPC, PCB, similar applications, and also in semiconductor packaging as well. Okay, works. So quick introduction into the company, introduction into the technology because it's new, so I feel like I still need to tell how it works. And then on the results that we had for different applications for that and what we are looking into future development. So as I said, we are laser guys. We are based in Vilnius, Lithuania, if I may say so, even if it's a very dragged around expression, valley of lasers with a thriving ecosystem. And we are building laser machines for mostly ultra short pulse laser machines for 13 years now. And working in, now mostly focusing on SSAIL, but also on some other electronics and semiconductor applications with silicon carbide, photovoltaics, some run-of-the-mill laser micromachining applications, and working worldwide. Most of our installations are in Europe, but also the first one in US was last year, and also Asia as well, was where the market is, of course. We can skip that. Let's talk about technology. So SSAIL stands for Selective Surface Activation Induced by Laser. It was invented and patented by Center for Physical Science and Technology. If you stop by our booth, we have the main inventor of the technology as well. So you can ask more deeper technical questions that you can ask of me. And the way it works, we have a standard any dielectric substrate, can be glass, can be ceramics, can be polymer. Pretty much we tested, if we take different grades into account, I don't know, several hundred of different materials. We treat it with laser, where we want copper to plate. And after that, it goes into activation solution and electroless plating. And copper plates only where we did laser treatment. Another good thing is that after the laser process, before the chemical process starts, we can store it without any limitations. So basically, if it's you can do a bunch of laser parts and then plate them all together in a big batch. And it can work for 2D circuits, like here it's directly on glass with copper, nickel, gold, and then standard SMT process. It can be vias, so drilling vias and also plating them in the same process. And it can be 3D structures, like in this case edge wrapping, but it can be some molded interconnected devices, so fully 3D. And another good thing is that adhesion of the process is very high. We form chemical connection between the copper and the substrate. And in many cases, when we are testing the substrate, testing the adhesion, it's the substrate that gives in. We break the substrate instead of having delamination of the copper. And some of the examples we tested for properly with automotive companies, with Stellantis for automotive requirements. In many cases, we are doing just a shortcut. So basically, you take the prepared sample, put it into boiling water for 2-3 hours. After that, do the Scotch tape and measure resistance. And if it is within, say, 3-5%, usually good to